ahead and begin.
So the topic I want to talk about today is quadratic functions and inequalities.
And maybe we'll just start with some basic facts. If I asked you to solve something that looked like that, what tool would you want to use? Yeah, there's a formula that does it. It has the advantage that it'll always solve any degree 2 polynomial equation. Sometimes it gives you answers that aren't real numbers, but it's doing the best it can. It just turns out there are no real solutions to some quadratic equations. Sometimes you can also play this game where you factor on a thing. Doesn't always work. When it does, it's a little bit easier than a quadratic formula. You can also always complete the square and then use that to solve. No reason one of those tools is always better than the other. Just different tools to have in your head. Maybe I'll point out just one last thing. If you graph something like this, you'll wind up with a parabola. So I guess it'll either be upward opening or downward opening. When will it open upward? When A is positive. So there's just some stuff to keep in mind for what we're going to do today. So I want to solve some degree 2 inequalities. And on this first page, I'm both going to try to motivate why to do that with something that'll feel vaguely like an applied example, along with an incorrect strategy. And it's a strategy that'll feel very tempting. You'll also tell me where it goes wrong. So let's do this. So Dennis Mitchell has snuck into the backyard of one Mr. Wilson and is playing toss with a ball. He's not supposed to be doing that, so there's some measure of risk involved. Let's put some more facts out here. So the height of this ball as a function of time is now given by -5t squared. Right, this term that comes from gravity close to the surface of the Earth, if you want to use more digits than 4.98 is closer to the acceleration due to term you would get from acceleration due to gravity, plus some term from initial velocity. Height in meters, time in seconds. Mr. Wilson is inside on the second floor of the house reading a newspaper. When the ball exceeds a height of 7 meters, it enters Mr. Wilson's field of vision. So let's answer this question. For each toss, at what times is the ball going to be in Mr. Wilson's field of vision? So, how can you express that as an inequality? Unravel what's in this sentence. When the ball is at height 2 meters, is it in Mr. Wilson's field of vision? Under what circumstances is the ball in Mr. Wilson's field of vision? Yeah.
Anything above 7.
Anything above 7. So, to address this problem, I just need to say when is the ball at a height that is greater than 7 meters. That sounds like an inequality, right? I want to know when is height greater than 7 meters. Oh, cool. I have a formula. -5t squared plus 15t is bigger than 7. all of the distances are in meters, all the times are in seconds, so I don't need to worry about silly unit conversion issues. All right, that looks like something we can solve. Nice. I am going to do something incorrect in a moment. So here's a strategy that I'll follow. There will be some flaws to it. Let's subtract 7 to the other side. Turn it into something that it looks like the quadratic formula knows what to do with. Negative 5t squared plus 15t minus 7 bigger than 0. All right. So that now says by the quadratic formula that x is bigger than negative b plus or minus.
Zoom problems.
Oh. What was the complaint?
It went out of focus completely.
Oh, okay, yeah. Its default setting is to focus on whatever's closest, and that's the back of my hand sometimes. There's a button that I need to remember to press. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's not where I was supposed to write that, but that looks like something we can now evaluate, right? Let's just work out what that is. Negative 15 plus or minus the square root of 25 minus, so let's walk that out. 4 times 5 is...
Why is it 20?
Oh, it shouldn't be. It should be 15 squared, shouldn't it? That's my fault. 15 squared. That would have screwed everything up. 15 is a square that's bigger than I'm comfortable computing by hand. But 4 times 5 I'm okay with saying is 20, all over negative 10. And let's just get approximations for those two things. So, I don't know, I guess I just have to like...
225.
Oh, that's 15 squared?
Yeah.
Shouldn't your
Okay.
7 be negative?
Shouldn't my 7 be negative? Let's see. So this term would be b squared minus 4, so there's a minus for the 4, times a, so that should be a minus 5, and a minus 7. So there should actually be 2 more negative signs there, which would cancel. So I just like pre-cancel 2 of the negatives. That's a fair complaint. Anything else that looks suspicious? I don't know if it was a straight up oversight on my end or if it was like intentionally canceling those negative signs, but it worked out okay. All right, let's use a machine. That's all a bunch of complicated numbers. All right. Parentheses matter, negative 15. Let's do the plus 1 first. Square root of 15 squared minus 20 times 7. That might be 140, but maybe I'm not feeling comfortable enough to make that replacement. Divide by negative 10. .58 seconds. And when I put the minus choice there, 2.4 seconds, 2.42 seconds. All right, we feeling good? So it looks like this boils down to x is greater than 5.8 seconds, and x is greater than 2.42 seconds. 0.58 seconds. And I don't know, if you like draw this, there's 0, there's 0.58 seconds. Be an open circle there. And then it goes on forever. And then there's 2.42 seconds a little bit later, and it's everything from then on. So, how would you interpret these two? if you wanted to put this into interval notation, what would you say? Yeah, if you just wanted like either one of those two things to be true, I guess it would be 0.58 to infinity. If you want both of them to be true, it's like 2.42 to infinity. Either way seems a little bit suspicious because if I just take a ball and throw it up in the air, do I expect it to stay above a height of 7 meters forever? So there's like something bad here. Any thoughts about what it is? There's not like an arithmetic error, or there might be, but that's not like the main error. There's like a fundamental logical error in what I did.
So wouldn't it be that the ball would be visible when it hits 0.58 seconds and until it gets to 2.43 seconds?
Yeah.
So then it would be 0.58 to 2.42 inclusive.
Yeah, this seems a lot more inclusive. Inclusive or exclusive. There's a strict inequality there. I'm going to go with exclusive. But like, with anything that seems like an actual application, it's hard to say if you like want inequality or with strict inequality or not. I think that seems like a significantly more reasonable conclusion anyway. That the first time it's at height 7 meters, it enters its field division. The next time it leaves. But like this logic just said I had two inequalities. They're both bigger events. Like, what's wrong? So I used the quadratic formula, right? Does the quadratic formula do anything with inequalities? No, the quadratic formula only applies to equalities. So, it turns out this step is just fundamentally flawed on a logical level. Quadratic formula works for equality, not inequality. You cannot directly use the quadratic formula to solve an inequality. But you can do something because, as you pointed out, when the height is 7 meters, those are the times when either the ball is entering the field division or leaving. So if I can find those 2 points when it enters or leaves the field division, I've done basically all the work. I just need to interpret the inequality in light of that. So, what do you think? Does that give like a strategy we could follow to solve this correctly? I think so. And maybe we'll even motivate by looking at a graph. Let's draw a cartoon graph. So if there is time on the horizontal axis, height on the vertical axis, then I expect the graph to wind up looking something like that, right? You throw the ball, it goes up for a while, it gets to that vortex point, which we could compute if we wanted to, but I don't want to, and then comes back down. There's this height of 7 meters. It looks like all the times between are the solution to the inequality. That feel reasonable? All right, so we have a strategy. Let's fix this strategy. The quadratic formula applies to equality. So, let's ask this question first. At what times does the ball enter Mr. Wilson's field division? Those two?
Yeah.
Why? Well, it's because we just need to solve height, negative 5t squared plus 15t equals 7. And I don't know, we just used the quadratic formula already. It's at t about 0.58 seconds and t about 2.42 seconds. Those x's should be t's, 0.58 seconds, 2.42 seconds. So those are the times when it enters or leaves Mr. Wilson's field division. So I guess that means either it's not visible to begin with, then it becomes visible and then stops being visible. Or the other strategy possibility is it was already visible and at some point stops being visible and then comes back into Mr. Wilson's field division. Which of those two is correct? The first interpretation or the second? Yeah, I mean, I think that what I said was like too many watts and very hard to parse. But the one where it enters the field division and then leaves. The ball is visible in between these times. So, for approximately 0.58 seconds to 2.42 seconds. Nice. That seemed like a strategy? Let's just formalize that. So, the remaining examples in this packet won't feel applied. They'll just be like, solve this inequality, and then you solve the inequality. You can imagine some sort of story about it if you want to, but I'm not going to try to impose it. So let's just cement the strategy by doing it a few times. Here's an example. So let's consider the polynomial function f of x equal to x squared plus 4x minus 12. Let's determine the x values that result in f of x bigger than or equal to 0. That is, I want you to solve that inequality. And as we explored last time, the tools we have for solving degree 2 polynomial equations don't immediately extend to inequalities. But if you can solve an equality, then you can just like do a little bit more to solve inequality. So, step 1, erase the inequality, replace it with an equal sign, solve that. That look like something you can do? Cool, I'm gonna have you do it, but maybe first I'll ask what strategies people think they'll use. How many people are planning on using quadratic formula? How many people are planning on trying to factor? How many people are planning on completing the square? Okay, cool. I'll let you do it. We'll come together once you have your answers. Oh, you have the answer? Or was there a question?
No.
Okay. Once you do have an answer, maybe compare with someone around you. Once you're feeling confident, then we'll come together. Cool. Let's hear it. What are the solutions to that equality? Yeah.
-6 and 2.
I hear a -6 and 2. People agree? Should I go through it? All right. Cool. I didn't check the answers, but multiple people seem to agree and you seem confident. I like that. -6 and 2, right? I guess when in doubt, I could like plug those in, but I don't think I'm going to. I think I trust you. All right, so let's put those on a number line, and let's think about what those mean. There's this point at -6, farther to the right is 2. So just as we saw previously, those are the places, I pressed the button, I shouldn't be doing that anymore. So here at -6 and 2, here are the endpoints of the solution. So it could be at -6 the inequality stops being true, or at -6 the inequality starts being true, and then the same thing at 2. So what does that mean? That means that if I can pick a single sample value to the left of -6 and see if the inequality is true at that sample value, I'll know what happens for all x values less than -6. So you can take a single sample value and it'll tell you everything. Give me a sample value less than -6. -8. So let's pick the sample value. X equals -8 and plug it in. We'll get f of -8 equal to -8 squared plus 4 times -8 minus 12. And all I need to know is the result going to be positive or negative? And maybe it's not quite easy enough to tell yet, but let's just simplify it a little bit until you're convinced whether everything is positive or negative. Let's see, -8 squared is positive 64. So this will be 64 minus 42 minus 12. Is it positive or is it negative? Positive. 64 is way bigger than the other two. I don't care how positive it is, it's positive. Because I don't actually care about t equals -8. Did anyone test a different sample value? Okay. A useful game to play that simplifies a lot of computations in this sort of circumstance is go extreme. Plug in like -1,000,000. And then like, you don't even need to do the computation because it'll be obvious which term's going to win. All right, give me a sample value between -6 and 2. 0. I think that's the easiest choice. Is f of 0 positive or negative?
Negative.
Negative. All right, I guess it's -12 in particular, but I don't care that it's -12, it's negative. So let's see, I got something positive here. I got something negative here. Maybe I should make a conclusion. So that means that for all x values less than -6, this thing is positive. So does that satisfy the inequality or fail to satisfy? I think it satisfies, right? I want them to be non-negative. So they're positive. So for all inequalities to the left of -6, these should be included. What about values between -6 and 2? Are they included or excluded? Excluded? Give me a sample value bigger than 2. 3. You can do that, and it'll walk. I'm instead going to go with 100, because then I think I can do the computation without doing the computation. So let's see, when you plug in 100, you'll get 100 squared, which is like 10,000. Plus 400, so definitely positive, minus 12. So that's like 10,000 plus 400 minus 12, yeah, that's positive. Because I don't care exactly what it is, like, I don't care exactly what that number is, it's definitely positive. X equals 100, f of 100 is bigger than 0. Did anyone actually just plug in x equals 3? What'd you get?
I got 9.
9, which is also positive. So, it looks like all of these should be included. So, is that enough information to just say what the answer is? Cool, then what's the answer?
It'd be all numbers negative infinity to -6, including -6. And then all numbers 2, including 2 to infinity.
Nice. How did you decide to include?
Because it's greater or equal to, and we know that when -6 and 2, they're equal to 0, because that's what we found out.
Awesome. I'm going to put that into want. When x equals -6, f of x equals 0, which is in fact bigger than or equal to 0. -6 is included. And maybe you don't have to like write that sentence, but it's worth like thinking that sentence when you do this sort of stuff. Be careful with your endpoints. That seemed like a pretty good strategy. Here's an alternative to this thing that I called step 2. Let's just try graphing this thing. I think we have enough information here to do a cartoon graph that's compelling enough. So we already have f of x equals 0 at x equals -6 and x equals 2. So if we were to graph this, I'd see an x-intercept at -6, 0, and an x-intercept at 2, 0. And now I'll ask you this. This function, if you want to graph it, would it be an upward opening parabola or a downward opening? Upward opening. Oh, so let's just try that. I don't care where the vortex is, so I'm not going to bother being careful with the vortex. I also don't care about the y-intercept, so I'm not going to be careful about that. I am going to try to draw a parabola that's upward opening and goes through those points. So, it's upward opening. And now remember, I want f of x bigger than or equal to 0. So this means I want y values bigger than or equal to 0. So let's just test some points on the graph. That point that I just highlighted in blue, does it have y value bigger than or equal to 0? Yeah, it's above the y-axis. So that means this x value is a solution. Oh, cool. So that just means all of the x values over here, these are solutions. I'm interested in bigger than or equal to 0, so that endpoint will be included. That x value, does that x value satisfy the inequality? No, the resulting y value is negative. So all of these will be excluded. And then after you get past 2, they'll be included again. So we get the same answer, -infinity to -6. Oops, you can never include -infinity, together with 2 to infinity. Did that feel a little bit easier than plugging in a bunch of sample points? Yeah. So like when you already know what the graph looks like, you can bypass the bit where you actually have to do the arithmetic. You just have to be careful with endpoints. That feel pretty good? Think you're ready to do a full example on your own? Here is one full example for you to do on your own. Solve x squared plus 4x minus 5 strictly less than 0. I guess complete step 1 that's higher up on the page using whatever tool you like to use to solve quadratic equations. Then use either step 2 or step 2 alternate to solve the inequality.
Cool. People feeling good? People want more time before we discuss? All right. Well, let's hear it then. What is the solution to this inequality? Sean,
-4, 1.
like that?
I can't see it.
Oh, sorry.
Or excluding.
Do I hear a second?
I got -5. I got negative, or I got 5 -1.
1, -5.
All right.
Wait, yeah, I got it. Yours be -5, or yours be -5.
Cool. So we're gonna go through it in a second, figure out like where the disagreement's coming from. But let's also play a quick game of, let's suppose you have got yourself down to one of those answers. How could you like check?
You could just plug each of those in. Or, like you could factor them.
What do you mean?
Like you could do x -1 and x plus 5 and factor them to see if you get that question.
Oh, cool. So if like finding those roots came from factoring, you could check factoring it by saying, well, like, if this is the solution, then it had to come from x -1, x plus 5, so you could FOIL that out. That's not unreasonable. Yeah,
Plug the values back in, see if
yeah, you can plug some values back in. I guess like this one says that -5 should be excluded, so let's plug in x equals -5. Gosh, -5 squared plus 4 times -5 minus 5.
That is 0.
And that is 0, I think. Cool, so that is suggested that -5 should be an endpoint. Maybe I'll propose one last one, that's a great idea. And then like, if you're still unconfident, check more endpoints. Like check the other endpoint, see if it also gives you a 0. Check a point in between, see if it's actually a solution, then you're like, really be confident. Here's another one, think we could look at a graph? Like a computer generated graph? Yeah. And like, even when I tell you to show all your work, you can always graph behind the scenes, you don't even have to tell me. X squared plus 4x minus 5. And maybe just to be like, really confident, x squared plus 4x minus 5. I want to know when it is less than 0. Alright, so it looks like x values between -5 and 1. And Desmos is putting the dashed lines that says that those values are actually excluded. Alright, so I think we have it down to a single answer. I think that I am convinced now, by checking a few things, that -5 to 1 is in fact the solution to this problem. Anyone want to actually go through it now?
I have a question.
Yeah.
So, you know how you said you can factor it out, right?
Uh-huh.
So when you factor it out, when you look at plus 4x, -5 plus x is not plus 4x.
Cool, let's play the factoring game. So let's see, if I want to factor this, I want to factor it as x plus something times x plus something. Those two things need to multiply together to be 5. Alright, because when you FOIL it out, like you'll have last times last, and those will be the only terms without any x's. I guess that means one of them has to be negative, so let's just put a negative sign there. Give me two numbers that multiply together to be -5.
5 and -1.
5 and -1 is 1. I guess the only other option is 1 and -5. They also need to add together to be 4. So let's add them together and see what we get. If you add those two together, do you get positive 4? Alright, it looks like those are the two. So x plus 5, x plus 1, x minus 5.
Now,
So
It's x plus 5, 1, x minus 1.
X plus 5. Yeah, because 5 is the one that has the positive in front of it. Yeah, okay, thank you. I did a silly. X plus 5, x minus 1. And to check, I'm going to FOIL x squared minus x plus 5x is plus 4x minus 1. Okay, so there's the factoring. Does that agree with what you did? Okay, now I need to set this equal to 0. So x plus 5, x minus 1 equals 0. That means either x plus 5 equals 0, or x minus 1 equals 0. All right, when is x plus 5 equal to 0? X equals negative 5, I guess. And this one gives x equal to 1. Does that help?
I didn't do the extra step, that's fine.
Oh, okay, this step where you like actually split it? Yeah, so it's really easy if you go from a factoring strategy that if you like don't break it up, it's really easy to accidentally say the solutions are negative what the actual solutions are. So you really need this mindset where you're breaking it into two separate equations. And sometimes it's useful to write it, sometimes you can do that stuff in your head. Nice. So, this seems like a fairly robust strategy. In all three of the examples we've done so far, we've been in a situation where when you solve the quadratic equation that you're interested in, you wind up with exactly two solutions. Do you always wind up with exactly two solutions to a quadratic equation? What are the other options?
One solution or no solutions.
Yeah, sometimes there are no solutions, like when you get a negative under the square root, or, yeah, well, that's it. Or sometimes you get just one solution. In order to figure out what to do in those circumstances, let's actually just see those circumstances appearing. So let's try to do this one. Let's try to solve g of x bigger than or equal to 0, where g of x is x squared plus 4x plus 12. So step 1, let's solve the equation. If you want to not listen, great. I'm going to just use this as an opportunity to do like completing the square to solve an equation, just to like see it happening. So I guess to do that, I want to rewrite that as x squared plus 4x. So I guess that means 2bx will be 4. So b had better be 2. So then I need plus b squared. So that's another plus 4, which I can pull out of the 12, leaving me with another plus 8. X plus 2 squared plus 8. So let's start by setting that equal to 0. So that means x is a number that when I add 2 to it, and then square it, and then add another 8, has to be equal to 0. Does that equation have any solutions?
The solution is minus 2. Oh, no, equal.
Minus 2 won't do. So you'll have minus 2 plus 2 squared is 0, plus 8 is 8.
But, yeah, so that doesn't work.
So if you like, that's like, what you found I think was the x value where the vertex is.
Yeah.
Is a square ever going to be negative 8? No, a square is always positive. But x plus 2 squared can't be negative 8. This has no solutions. Those of you who use the quadratic formula, did you get a consistent conclusion? Yeah, you wound up with a negative under the square root. But one of the points of completing the square is if you can do it, which sometimes it's easy enough to do, you can read off the solutions from there. Okay, so equality has no solutions. So what conclusion do you think we should make? Is the conclusion going to be just there are no solutions? I hear no real numbers. And whenever you're studying inequality, you shouldn't think about complex numbers. Those don't really have a sense of
inequality. I don't know if I is bigger than 1. Well, let's think about it. Maybe I'll think about it via graphing. Upward opening parabola or downward opening parabola? Upward opening parabola. And it never crosses the x-axis, because it has no x-intercepts. So I guess that means, because it's upward opening, it just always has to be above. Right, if the vortex were down here, well, it would have to cross the x-axis. So, whatever the graph looks like, it'll look something like that. So by looking at a graph. So, tell me, does that graph have any y values that are less than or equal to 0? No. So what is the conclusion to this problem? There are no solutions to this inequality. G of x is always positive. There are no solutions. Maybe in order to see that that's not always the case, what if I asked you to solve g of x bigger than or equal to 0? So this is just like a second problem. What if I asked you to solve that? What would you tell me the conclusion is then?
The all real numbers?
I think it's all real numbers. This thing is always positive. So in the case that there are no solutions to equality, I bet that the resolution to the inequality is always going to be either nothing or everything. The only other case is maybe there's only one solution. Here's another one, x squared minus 2x plus 1. Let's solve that is bigger than 0. And let's start with phi of x equals 0. And I don't want to do it this time. What is the solution to that equation? I hear a 1? Do I hear a second for 1? Cool. That was quick though, so I'm going to give people a second. Quadratic formula or factor?
Factor.
Yeah. When you can, it's easier to factor, but you can't always factor. Nice. So there is exactly one solution to this equation. And now we'll see what people want. Should we check a sample point or draw a graph? Sample points? Graph? Cool. Seeing kind of votes for both. Last time we looked at a graph, so let's check some sample points. So what's the game? I saw a single solution at x equals 1. So that means I guess I can check sample points to the left and right and see what happens? What's a sample point to the left of 1? 0. Plug in x equals 0, what do you get? 1. Is that something that makes me happy with this inequality or unhappy? Does it give me a solution?
Yeah, because 1 is positive, so.
Nice. So that is a solution. So that tells me all numbers to the left of 1 should be included. What's a number bigger than 1 I could check? 2. What's phi of 2? Also positive. So that means all numbers bigger than 1 should be included. What about x equals 1? Should that be included?
No.
Why not?
Because it's 0.
Yeah. I want to know when phi of x is bigger than 1. When x equals 1, phi of x equals 0 is not bigger than 0. So I should exclude x equals 1. So it looks like I get negative infinity to 1 together with 1 to infinity. And I think that covers all of the possible cases that can happen via just like these examples. In order to just like formalize this, I'm going to talk through like a flowchart on the next page. So whenever you want to solve a degree 2 polynomial inequality, step 1, forget about the inequality. Well, for a degree 2 polynomial, f of x equals a plus bx plus c, in order to solve an inequality involving that, I guess there are 4 possibilities. Step one, solve equality. There are three things that might happen. There might be exactly two solutions. There might just be one solution. There might be no solutions. In this generic case that there are two solutions, well, if those two solutions are x0 and x1, and you want to solve a strict inequality, well, either it's all the numbers in between, or it's all the numbers beyond, excluding those points. Excluding because strict inequality. If you want to have a non-strict inequality, well, you get to include endpoints. How would you decide between those two options? What could you do?
Another one from
Cool. What was the other thing that we did to check that? I mean, the other thing we did is we like hand drew a graph, right? Neither strategy is strictly better than the other. They're both just options you should have in your pocket. If you have a single solution, well, then your two options are either only that number is the only solution to inequality, because it'll solve equality, or everything is a solution, or everything but that number solves the inequality, or nothing solves the inequality. If there are no solutions to equality, the answers are either everything or nothing, and in each of these cases, you'll determine by plugging in some test values or looking at a graph. And so to wrap things up, I have 2 minutes. Let's do an example without doing any computations. Without doing any computations, here's a multiple choice problem. Which of those options might be the solution to this inequality? And if I'm going to have you do this without doing any computations, I think this is very much going to be a process of elimination. Is there anything you can disqualify easily?
B and D,
B and D. Why B and D?
because they both have some sort of including.
Yeah. Strict inequality will exclude endpoints. If whenever you have a strict inequality, endpoints are excluded. So it's just down to A and C. How could you figure that out without doing any computations? Or by doing a computation, you got it.
I said, I think, because, let me just make sure I'm thinking what I'm thinking.
I hear a call for, do I hear a second for C in the meantime? Cool. You've got some backup, so.
I said C because if you plug in 0, it's less than the drop.
Test x equals 0. And I guess you have to have some intuition that like 0 is between those two things, but
That's why it's not A.
that's why it's not A. So 0 is between those two things, and 0 is disqualified. Neat. That's like the with computation strategy. The without computation strategy,
You can see just like negative, or it starts with negative infinity, because you see options are either negative or 0.
uh-huh.
You can just, that should be another viable strategy.
Yeah. If you were to graph this thing, you'd get an upward opening parabola. And like, I guess these two endpoints have to be those two numbers. So it's either, and where is that positive? It's positive in the things with infinities. Cool. So, if anyone is very impatient to get their hands on a paper copy of that review, I should have them in my office by the time my office hour happens. Is that what you're gonna ask me about?
I was just wondering if there's anything else.
Oh, no, that's it. I'm about to end the class and saying goodbye. It's gonna ramble for a while.
Yeah, is the exam launching soon? Or quiz? I thought I might have just heard.
Monday.
Monday? Next Monday?
Yep.
Okay, thank you so much.
Will you end up on Wednesday then, next time we have class?
That's my intent. They're also online, so if you want to see them that way.
Quick question. So I have two but different levels for the K value. I could start again, right?
From what
Okay, tell me where your number is coming from.
So I did, because it's C, so 19 minus B squared, so negative 84 squared, divided by
In my high school career.
negative 12 is 2A. And I'm getting, when I add them together, I'm getting 6.
Yeah, it's on the course website.
Okay, I just want to double check.
Yeah, so let's go through it. So the first thing that I think I want to check is let's just see that it's wrong by maybe looking at a graph. So, pull up the Desmos. So let's graph the original thing. Negative 6x squared minus 84x
plus 19.
plus 19. And there it is. And what you just told me is negative 6 x minus 7 squared plus 607. Okay, so the graph is incorrect. And I guess like,
I think I'm confused on how to find the C point.
yeah, let's go.
Because I did it for the other one too, and I also got it on the other problem on a different one.
Yeah, so whenever you have ax squared plus bx plus, that will be the same thing as ax plus b over 1b squared. I guess you want a negative sign there. So, but you've already got that accounted for. Plus c minus b squared, right?
Oh, it's 4A.
Yeah.
I think that's where I'm at.
All right, well, let's just test that in this case. For this problem, oh gosh, I guess this C will be 19 because of the 19 minus, it gets squared anyway, so 84 squared over 4 times negative 6. And that's way too big enough to compute by hand. 19 plus 84 squared divided by 24. And in order to check, that C is also the Y value of the vortex.
Okay,
And yeah,
thank you. I have it written in my notes wrong. I had it 2A instead of 4A.
ooh, did you? That means I want to.
Well, I might have wrote it wrong.
I remember feeling pretty floppy when I wrote it down. Okay, eventually I did put a 4 in.
Okay, sounds good. Thank you so much.
Yeah. And in fact, when in doubt, I'm a bigger advocate of like knowing this piece of the formula is way less important in my mind. Because if you know that much of the formula for completing the square, you would just like FOIL it out and see what you need to add or subtract, and that's what that form is.
Chapter 2 notes this week.
Yes. And I do not have any copies with me. Can you make it up to my office immediately after class?
I have a class right after this.
Can you make it to my office at like 1 o'clock when I have my office hour?
Yeah.
And by then I'll give you a copy.
Alright, thank you.
Yeah. In the meantime, I guess you're taking notes the old-fashioned way.
Can I come and get one
Yes.
after class as well? Like
Yeah.
dark? Okay.